Hello students, today we will be solving the IB Math AHL May 2025 paper 2 TZ1 question number 12. This is the last question of this paper. You will be getting the solutions for the first 11 questions from this paper and the solutions of the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve question number 12. The maximum mark is 20. Consider the family of functions fn defined by fn of x equal to sigma r ranging from 0 to n, negative 2x squared whole raised to the power of r, where x is a real number and n, this is n is a natural number. Part A's question is show that fn is an even function for all values of n. Okay, so for even functions, what is the definition of an even function? It is f of negative x should be equal to f of x. So this is the definition of an even function. Okay. So in place of x in the expression of f of x, if we substitute negative x, that will be the expression of f of negative x. So since fn of x is having this expression, therefore fn of negative x should be equal to sigma r equal to 0 to n. Every other portion will be the same. Only the x will be changed to negative x. Okay. So negative 2 times negative x whole square, this is negative x square, raised to the power of r. Okay. So this is equal to r equal to 0 to n, negative 2, negative x square is x square, raised to the power of r, which is nothing but equal to fn of x. Okay. So this is equal to fn of x. So therefore, fn of x is an even function for all values of n, because we have not changed any value of n. It is r is ranging from 0 to n. So we have not done anything with n. So this is true. We have proved this relation between fn of negative x and fn of x without changing the n part. So we can say that it is true for all values of n. Okay, shown. Part B, it is having two further subparts. The I is saying show that if 3 of x equal to 1 minus 2x squared plus 4x to the power of 4 minus 8x to the power of 6. So we have to, this is the sigma notation. We have to expand this. Bi, it is if 3 of x, that means n equal to 3. N equal to 3 if 3 of x should be equal to sigma r equal to 0 to n, that means 3, and it is negative 2x square raised to the power of r. So this is equal to negative 2x square. The first value of r is 0. So raised to the power of 0 plus negative 2x square raised to the power of 1 plus negative 2x square raised to the power of 2 plus negative 2x square raised to the power of 3. Okay, last value of r will be equal to 3. So this is equal to anything raised to the power of 0 is 1. Negative 2x square raised to the power of 1 is minus 2x square. And minus 2x square raised to the power of 2, it will be minus 2 square and x square raised to the power of 2. Okay, let me write it separately first of all. Minus 2 square and x square raised to the power of 2. And the last term is minus 2 raised to the power of 3 and x square raised to the power of 3. So therefore, if 3 of x is equal to 1 minus 2x square and minus 2 whole square is plus 4. So it is plus 4 and x square raised to the power of 2 is x raised to the power of 2 times 2, which is 4. And minus 2 raised to the power of 3 is minus 8. And x raised to the power of 2 times 3 is 6. Okay, you can see this. If 3 of x, 1 minus 2x squared plus 4x to the power of 4 minus 8x to the power of 6 shown. Okay, this was bi, and now I write down a similar expression for f4 of x in ascending powers of x. Of course, when we are expanding this, we are getting terms containing ascending powers of x. Okay, so we do not have to worry about that part. So in this case, the n value will be equal to 4. So bi n is equal to 4. So therefore, f4 of x should be equal to sigma r equal to 0 to 4 and minus 2x square raised to the power of r. Okay, and now we have to expand this. So let me just write it over here. This is equal to minus 2x square. First value of r is 0 plus negative 2x square raised to the power of 1 plus negative 2x square raised to the power of 2 plus negative 2x square raised to the power of 3 plus negative 2x square raised to the power of 4. Okay. So therefore, if 4 of x will be equal to, again, starting term is, the first term is 1 minus 2x square plus 4x to the power of 4. These 4 terms, the first 4 terms will be the same, and minus 8 x to the power of 3, 6, and minus 2 raised to the power of 4 is 16, plus 16, and x square raised to the power of 4 is x to the power of 8. Okay, so therefore f4 of x is having this expression. Okay, consider the function f of x, limit n tends to infinity of fn of x defined over the domain x is greater than negative k but is less than positive k, and k is a positive number, k is greater than 0. The largest possible value of small k is capital K. Subpart C, it is also having two further subparts. The first subpart is saying find the value of K, capital K, giving your answer in exact form. Okay, you cannot give a decimal answer because it is paper 2, you will be having access to the calculator, but the answer should be given in exact form. Okay, so first of all, let us see f of x is limit n tends to 0, fn of x. So it will be an infinite series and the domain will be x is greater than negative k but is less than positive k. Okay, and k is a positive number. So let us start from here. It is f of x, limit n tends to 0. I'm writing the question first of all. The expression fn of x. Okay. So this is limit n tends to infinity. And in place of fn of x, I am writing sigma r equal to 0 to n and minus 2 x square raised to the power of r. Okay. So therefore, f of x should be equal to, we have got the first 5 terms. So let me just write them. 1 minus 2x square plus 4x to the power of 4 minus 8x to the power of 6 plus 16x to the power of 8 and plus dot dot dot, because it is an infinite series. Okay. And we have to get the value of positive k. Okay. So x is between negative k to positive k. Let me write this. And k is a positive number greater than 0. Now, this is an infinite series, and we see that this is a geometric series because it has a common ratio. So, you see the common ratio, this is a infinite geometric series. With a common ratio equal to negative 2x square over 1 or 4x to the power of 4 over negative 2x square. This is equal to negative 2x square. Okay, the common ratio is negative 2x square. And because they are saying the domain is this, that means this will be a convergent geometric, infinite geometric series. Okay. So, for this infinite geometric series, to become convergent, for convergent geometric series, what is the criterion that has to be satisfied? The common ratio R should be between negative 1 and positive 1. And over here, the common ratio is negative 2x square. So this should be between negative 1 and positive 1. So negative 2x square should be greater than negative 1 and should be less than positive 1. And now we have to get to x. So first of all, let us divide the 3 parts by negative 2. And as soon as we are dividing with a negative number, the inequality sign will be changing. So negative 1 over negative 2, the less than, this one is greater than with respect to x square. So this is getting changed to less than with respect to x square. Again, I'm repeating, x square is less than half, and it should be, this will also be changing. It will be 1 over negative. So this implies that negative half is less than x square is less than positive half. Okay. And question is asking for the maximum value, largest possible value of k. X is between negative k and positive k, and the maximum possible value of k should be the capital K. That means this one. Okay. So, since we are interested in the maximum, I am taking only this part. Okay, so therefore x square is less than half, and taking the square root of both the sides, we get x is less than 1 over square root of 2. Okay, so therefore k is equal to 1 over square root of 2, or you can rationalize the denominator and you can write this as square root of 2 times 2. Am I getting this? I am multiplying both the numerator by root 2 and the denominator by root 2. So root 2 times 1 is root 2 and root 2 times root 2 is 2. So you can write the answer as k equal to 1 over root 2 or k equal to root 2 over 2. Okay, so this is the value of k. So but I express f of x as a rational function in the form 1 over a plus bx squared, where a and b are constants to be determined. Okay, so now that we know that this f of x is an infinite geometric series, and in order to be in order to be convergent, in order to be a convergent infinite geometric series, we have got the restricted domain for what values of x can we have the common ratio between -1 and +1, and we have got the value of capital K. So we can use the formula for S infinity, because this is an infinite geometric series, a convergent infinite geometric series. So we can use the formula for S infinity. Okay. So CII is infinity equal to U1 over 1 minus R. Okay. And what is U1, the first term? It is 1. And what is the common ratio? It is minus 2x squared. Okay. So U1 is equal to 1, R equal to minus 2x squared. So therefore, S infinity equal to 1 over 1 minus 2x squared equal to 1 over 1 plus 2x squared. So therefore, f of x should be equal to 1 over 1 plus 2x squared, where e is, therefore, e is equal to 1 and b equal to 2. Okay. The function g is defined as g of x equal to f of x for x is greater than or equal to 0 but is less than capital K. Support D, again having two further supports, the I is saying justify that G inverse exists. G inverse will be existing if we can prove if that G of x is a one-to-one function. We have inverse functions of only one-to-one functions. Okay, and they have taken a restricted domain for f of x. So it is not obvious, but it is expected that G inverse will be existing, but I cannot say I expect, I have to give the proof. So it is paper 2, let me use the calculator. And we have seen that the f of x expression is 1 over 1 plus 2x squared. Okay, so I will be taking the g of x expression as 1 over 1 plus 2x squared, and I will be taking the domain as x is greater than or equal to 0 but is less than 1 over root 2, or you can write root 2 over 2. Okay, so d I g of x is equal to 1 over 1 plus 2x squared, and x is greater than or equal to 0 but is less than 1 over square root of 2. Okay, now we will be graphing. 1 over 1 plus 2x squared, and we have to change the domain. So menu and then Windows Home and Windows settings, and x is between 0 and this, let me keep the x-min as -1. I want to see the y-axis, and x max is 1 over root 2. So 1 divided by square root of 2. Okay, and x min I can keep it as, let me keep it as -1, and x max I can keep it as, okay, 4. Oh my goodness. -1 is too much towards the left, so I can take it the x min as 0.3, -0.3. Let me take. So x min, I'm just taking it as -0.3. That is the only change that I'm doing, and you can see that from 0 to, and this point is 0.707, which is 1 over root 2. It is constantly decreasing. It is a decreasing function, and you have to give the graph, a rough sketch of this graph, to show that it is decreasing. It is not having any turning point. It is not turning anywhere. That's, for some part it is decreasing, and for some other part it is increasing. If you have a turning point, only then can you have a many to one function. Only then can a horizontal line cut the graph at more than a single point. But if you have a strictly increasing or strictly decreasing function in a restricted domain, of course, then you don't have any turning point, and it is a purely one-to-one function. Okay, so you'll be having the inverse. But since I am trying to graph this, let me find the y values. So graph trace, and when x equal to 0, x equal to 0, you can find it will be 1, but anyway, x equal to 0, it is 1, this point. And when x equal to 1 over root 2, what is it? When x equal to 1 over root 2, y value is 0.5. Okay, so I need these two y values also to graph the g of x function. Okay, so this is the graph of y equal to g of x, and we can write from the graph. This actually is, this point is not included, this point is included. From the graph of y equal to g of x, x greater than or equal to 0 but is less than 1 over root 2, we find that g of x is a decreasing function with no turning point. Therefore, G inverse exists. G inverse of x exists. Okay. So, but it is saying find G inverse of x giving its domain, and these two together is carrying 6 marks. So, this one will be maybe carrying 2 marks, and this will be carrying 4 marks. So, you have to give the expression also for the G inverse of x, and then specify the domain, state the domain. Don't just jump to the domain, because you will be getting the domain. What will be the range of f g of x will be the domain of G inverse of x, and you can get the range of g of x function from the graph using your calculator. We have already drawn the graph, so we know the domain of G inverse of x function. But since this contains 4 marks, so you have to give the expression for G inverse of x as well. Okay, don't just give the domain. So this is y in place of g of x. I am writing y equal to 1 plus 2x square, and now I will be writing x in place of y and y in place of x. So 1 over 1 plus 2y square, and I have to make y the subject. So 1 plus 2y square times x is equal to 1, or x plus 2xy square equal to 1, or 2xy square equal to 1 minus x. Therefore, y square equal to 1 minus x over 2x. So, therefore, y equal to, we are taking the square root, so plus minus square root of 1 minus x over 2x. Don't forget to write the plus minus. But what will be g inverse of x? G inverse of x will not be having both the signs. So, g inverse of x will be what? It is the range. And what will be the range? It will be the domain of the original function. So the domain of the original function is between x is greater than or equal to 0, but is less than 1 over root 2. All are positive numbers. So the range will be all positive numbers starting from 0. So therefore we have to use the positive square root. Okay. Because the domain of g of x is x is greater than or equal to 0, but is less than 1 over root 2. Okay, all positive numbers. So you have to take the range also as all positive numbers. So this is the expression for g inverse of x, and now we have to give the domain of g inverse of x. So domain of g inverse of x will be equal to the range of g of x. And we have already drawn the graph of g of x, and we are seeing the range is between 0.5 to 1. Okay, so therefore domain of g inverse of x is equal to x is greater than 0.5 but less than or equal to 1. Okay, don't include the equality sign over here because this point is not included. It is a hollow circle over here. Okay, the region R is completely enclosed. This is the region R by the curves y equal to g of x, y equal to g inverse of x on the x-axis and the y-axis. As shown on the following diagrams, the part E's question is find the area of R. And we are seeing that this is the point where the y equal to g of x and y equal to g inverse of x, they are intersecting. Okay, so we can divide this entire region R into two subparts. One will be this one and one will be this one, because for this region 1, we will be using the y equal to g of x expression, and we will be finding the area. This one is between y equal to g of x, the x-axis and the y-axis. And for this region 2, it will be between g inverse of x and this value of x. We have to find the intersection point and this value of x. Okay, so we have to get the x-intercept of g inverse of x, and we have to get the intersection point of g of x and g inverse of x. We have already graphed the g of x. We will be graphing this g inverse of x. Okay, the calculator and it is the square root 1 minus x over 2x. Enter. And we have to get the intersection point. Okay. So analyze graph and intersection. It is this one. 0. Obviously, whenever the original function and the inverse function intersect, that will be a point on the line y equal to x, because the inverse function graph will be the mirror image of the original function graph, where the mirror line is the y equal to x line. Okay, so therefore the x coordinate and the y coordinate, they have the same value, 0.589755 and all. We have to take correct to three significant figures, so I'll be taking 0.590. But if I have to give this answer, but since this is not asked for, I do not have to give this as the final answer. I need this as one of the limits of integration, upper bound of integration or lower bound of integration. I'll be taking all the 6 digits that they have given, the calculator has given. Okay, and this is one of the points that I had needed, and then I will be just moving like this, and I need to know the x coordinate of this, x intercept of g inverse of x. So analyze graph and 0, and which graph? It is this graph, and this is 1 comma 0. Okay, so obviously when g inverse of x will be equal to 0, when square root of 1 minus x over 2x will be equal to 0, or 1 minus x over 2x will be equal to 0. Okay, let me first of all write the point of intersection. So part E, the coordinates of the point of intersection between y equal to g of x and y equal to g inverse of x is with, okay, coordinates, so are 0.589755 comma 0.589755. Okay, and we need the x intercept, so the x intercept of y equal to g inverse of x is x equal to 1, or is the point 1 comma 0. Okay, so we had needed these two. So first of all, we will be taking the integral. It will be the integral of g of x. So it will be from 0 to the point of intersection. Okay, and the expression will be for g of x. So therefore area of R is equal to 0 to 0.589755 g of x dx plus 0.589755 to 1 g inverse of x dx. Okay, so what was the g of x expression? It was 1 over 1 plus 2x squared. So this is equal to 0 to 0.589755 1 over 1 plus 2x square dx plus 0.589755 to 1 the expression for G inverse of x is this one, square root of 1 minus x over 2x. Square root of 1 minus x over 2x and dx. And of course, we'll be using the calculator. So this is equal to, this is the calculator, and integral and lower bound and upper bound is 0.589755, and the expression is 1 over 1 plus 2x square dx plus the integral 0.589755 to 1, and this one is square root of 1 minus x over 2x, okay? 1 minus x over 2x, and it is dx. Okay, enter. Answer is 0.63528. So correct to three significant figures, it will be 0.65. Okay. So therefore, area of R equal to 0.65. Correct to three significant figures. So we have completed answering this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be motivating me, will be increasing my videos reach. So it will be helping me a lot. We meet again very soon in our next session. From our next session, we'll be starting to solve a new paper, that is paper 3. Till then, bye.